Scanning technology has improved so much over the years, they've gotten it pretty close. There's still some issues that come up, especially on scaling, and some people scan better than others, and some have equipment that's better than others, which helps. One of the main things that happens in a scan is if you can picture a sheet going through two rollers, and let's say one roller is not in the same orientation as the other axially, you can actually get a twisting effect on the sheet. Or if the operator puts the sheet into the machine a little off, the whole scan will be twisted somewhat at an angle from one corner to the other. And so that's what I want to talk about here when I get the PDF files and I import them into a CAD system. These are some things that I have to consider while doing that. So I want to show you briefly here how I import a scan and how it can be off a little bit. And let me go ahead and remove this one and reinstall it. So here we go. I'm going to pick my PDF scan, and it wants me to start it from the lower corner of the sheet. This happens to be a 24 by 72 inch sheet, and the scan was designated as a 24 by 72 inch sheet by the operator. Now here's what I'm talking about. If you notice, I'm touching the upper right corner of my page on the computer system, which is very accurate, and you notice the scan file goes up above it. So what I was talking about, the scan rollers could be off, or the operator could have put the page in a little crooked in the beginning, or they could have left a trailing end at the end of the scan, which would make it longer than a 24 by 72. So these are all the things to consider. All right, so I'm going to go ahead and place it, and we see that it looks long. Notice this horizontal grid line on this side of the sheet is a little bit above the page, and it's way above up here, but I want to use this as a guide. I want to see if there's a twisting effect to this scan. All right, let me roll over here. Okay, oops, excuse me. Here we go. Okay, so I'm going to come in here and look, and it looks like it's pretty horizontal, so more than likely this scan has a trailing edge on it. So I have to basically lower the scan down onto the page, and if there is anything off in scale, I make those adjustments as we go. The best way to get an accurate scaling is to know where a couple of points are on the whole sheet, preferably minimum of 3 points, and knowing the distance between each point. If they are at a right triangle with each other, let's say say I got 2 points, one here and one here. If they're perfectly horizontal on the paper, I can get the sheet oriented in my system horizontally here, as well as vertical. Now, as you can tell on this sheet, for me scaling, if I had a point at the bottom and one at the top, vertically oriented, I can draw a vertical line from the bottom all the way up through the top. And as I got to these points, which Phil put in here a nice set of points for me to use, if that line that I drew from the bottom comes up on either this side of it or on this side of it, then I know I've got a twisting effect on my scan that I can adjust as well. Okay, so once I get all that worked out, and it's tedious, it takes a little while, you get better as time goes on, then I trace them. And so here's the tracings. Let me turn the text on. All right, this is my tracing. After I trace them, I check them for scale. Once again, I really like to check them in a layout. Okay, a frame layout is really nice to verify your parts with. So I make a model of the parts, and over here I've got a layout, a side layout of a chair, the deck chair. And what we did is we located the parts from the floor up, and if you notice, my CAD program gives me real nice reference lines. If I touch a point, it lets me see a perfectly vertical reference line straight to the floor or straight up. I can also check horizontal measurements. So I can get these points located on these parts where they should be, let's say from the floor or from across each other. And one thing to note about measuring with a tape measure, if I'm given a measurement and I need, it's really nice to know how that measurement was taken. For example, check this out. If I took a measurement straight out from the chair horizontal with the floor, you notice that the measurement is hypotenuse along the part edge is going to be a little longer than it would be if I came straight out with the tape measure. Now, these are some things to consider when sending information on measurements. This point here was also located the same way, into the intersection point here, and that's pretty obvious. You can this one had to be straight across and straight down to the floor. Wasn't any issue. I can also find intersect points or tangent points on curves and locate them from the floor as well. This is a tangent point on this curve. It'll let me know horizontally from the floor where to drop that arc. So I can basically rotate these parts around and line them up. Okay, once I get that done, then I locate the holes. It's like I just drill them through both parts. After I get them located, then I trace where the parts intersect by using dot lines, match lines I call them. And that's what these are, is match lines. This one's for another part that goes on another model. And I trace match lines over all these. Okay. After I get all that done, I basically select all these parts individually, and I make what we call a block, which is basically a group of all the elements. I make a group of them, and then I take them and I copy them into the sheet over the ones that were originally traced, and I remove the originally traced ones because more than likely I've had to adjust on the model layout or the side layout. I had to make some adjustments to the heights and whatever the locations of the holes and stuff like that. All that is fixed before it's put back on the sheet. So I know that my sheet is done accurately. I locate them as best we can on the sheet, and then label them with my text, and voila, it's all done. Pretty simple process, just takes a little time, a little patience, and having good measurements really makes it helpful. Also having good scans, understanding how the scans work, so when we get scans done, we kind of know what to look for. When a person gives us a scan file, we want to watch for twisting effects or stretching or any other kind of weird stuff that can happen with the equipment out there. I certainly hope this video was helpful, and thank you very much for letting me work with you, and hope to get some more work soon. Thank you.